Essay of this chapter is particle in a box or a particle in an infinite square well potential. So we are considering a well-shaped box. It is a well-shaped box, square well-shaped box, and width of this such a box is capital L. So x equal to 0 will be our first boundary and x equal to L will be our second boundary. So this boundaries of this box, consider the boundaries. It has infinite height and a finite width. Such a box is known as infinite square well potential. So at the boundaries, what will be the potential? V is equal to infinity because the height is very large here. So at x equal to 0, potential will be infinity, and x equal to L, potential energy will be infinity. Inside the wall, potential is equal to 0. Now we are considering a particle of mass m which is trapped inside this potential well. It cannot escape from this potential well since these are two boundaries which has infinite height. So such a system is known as particle in a box or particle in an infinite square well potential. L is the width of the well. What are the boundaries? X equal to 0 and x equal to L are the two boundaries. At x equal to 0 and x equal to L, potential V will be infinity, and inside the well, the potential V is equal to 0. These are the main points that we have to be remembered while writing this essay. Now the situation can be represented by time independent wave equation. Here we are using time independent wave equation because potential energy does not depend on time, so that we can use time independent wave equation. So what is our independent wave equation? Dou square psi by dou x square plus 2m by h cut square e minus v psi is equal to 0. This is the time independent wave equation, equation number 1. Now we know that inside the well potential V is equal to 0. So this equation will become dou square psi by dou x square plus 2m by h cut square e psi is equal to 0 since V is equal to 0. Now dou square psi by dou x square plus k square psi is equal to 0. We have a constant here 2m e by h cut square that can be replaced by k square, a constant. K square is equal to 2m e by h cut square. Now we have to find this k square. For that I am assuming the solution psi is equal to a sin kx plus b cos kx. We are assuming a solution for this equation, that is psi is equal to a sin kx plus b cos kx, where a and b are amplitudes. Okay, k is the constant, k square is equal to m e by h cut square, x is the position. Now we are applying the first boundary condition. What is our boundary? First boundary is given by x equal to 0. Right? X equal to 0 is first boundary. So at x equal to 0, wave function is equal to 0. Because at x equal to 0, particle cannot exist. Particle will not exist at this boundary. So if the particle cannot exist in this boundary, the wave function will be 0. If there is no particle, there will be no wave function. Okay. So at x equal to 0, psi is equal to 0. Now applying these two conditions, these two values in this equation number 4, psi is equal to 0 is equal to a sin k into what is x? X equal to 0 plus b cos k into 0. That is 0 is equal to a into sin 0 plus b into cos 0. Sin 0 is 0, therefore we will obtain b into 1, that is b is equal to 0. So here this solution can be written as psi is equal to a sin ks, because here b is equal to 0. We are applying the first boundary condition. We will obtain b is equal to 0. The second term can be neglected. Okay. Now psi is equal to a sin kx, equation number 5. Now we are applying the second boundary condition. What is the second boundary condition? At x equal to L, psi is equal to 0. Because at x equal to L, it is a second boundary. Here the particle cannot exist. So psi is equal to 0. Okay. So at x equal to L, psi is equal to 0. Now we have the wave function psi is equal to a sin ks, because b is equal to 0. So that we have only the first term a sin kx. Now we are applying this boundary condition. At x equal to L, psi is equal to 0. Psi is equal to 0, which is equal to a sin k into, instead of x we have to substitute L, kl, which means either a is equal to 0 or sin kl is equal to 0. but I will say A not equal to 0 because A is amplitude. So the possibility is sin KL is equal to 0. Okay, sin KL equal to 0. We know that sin n pi is equal to 0. Sin n pi, that is sin pi is equal to 0, sin 2 pi is equal to 0, sin 3 pi is equal to 0, sin n pi is equal to 0. So that sin KL is equal to 0, sin n pi equal to 0. We can equate KL is equal to n pi, or k is equal to n pi by L. From that k square is equal to n square pi square by L square, equation number 6. Now compare equation 3 and 6 because already we have k square is equal to 2m e by h cut square. So that 2m e by h cut square is equal to, now we have obtained n square pi square by L square, right? So from here e can be written as n square pi square h cut square divided by 2m L square, where n is equal to 0, 1, 2, 3, etc. So that we can generalize this equation as En, because for different values of n we have different values of energy. So that En is equal to suffix, we have an n here. En is equal to n square pi square h cut square divided by 2m L square. This is known as energy eigenvalues. E1 can be written as pi square h cut square divided by 2m L square. E2 is equal to 2 square pi square h cut square divided by 2m L square. E3 is equal to 3 square this value. So that we can find different values of energy for different values of n. These are known as energy eigenvalues.